Okay, so problem set 7, and this week's video problem, we're introducing our pets. So this is my pet. It's a bird. Yeah. I also have a dog and a rabbit, but this one lives with me, so gets all the attention. Oh, you have a feather loose. Oh, okay, I'll fix you. Okay, let me just okay, I'll put you down. He likes to sit on my soldering iron. So he's a little engineer. He can solder, I promise. Yeah. So this video problem. Okay. So what we're doing is we're going to solve for the discrete. So we're giving a continuous signal. We're going to solve for the discrete signal, and then we're also finding for the discrete and continuous output. And yeah, and we also have t equals 1/1000, and then we have the filter, but we're not going to use the filter right now until later in the problem. Okay, so let's start. Everything I just said, pretty much. Yeah. Okay. One important thing. F max 2 pi over 400. Um, Yeah, and then so what we're gonna do is we're gonna check for aliasing first, and then I like using the frequency because it's just easier to look at because there's no pi, nothing against pi. I just don't. I just like frequency more. Um, so we have t is 1,000 hertz because it's just 1/1000, and you just flip it. It's 1,000 hertz, and then you do 2 pi divided by 2 pi 400 divided by 2 pi. You get your hertz is 400, and you multiply by 2, you get 800. 1,000 greater than 800, so you're good, no aliasing. Okay, and then 3 steps to convert continuous to discrete. So we're gonna copy it for every 2 pi t, or yeah, and then so it's gonna be 2 pi 1,000, and then so the right of it is gonna be 2 pi 1,400, 2 pi 1,600. It's gonna be flipped over, and so it's just gonna be continuing this every 2 pi, same thing. I'm just showing it like those three, but it'll be forever. And also the height is 1/t, so 1/1000 is 1,000 for the height. And then so you can multiply by t to get omega. And so I just showed one example, but you're just multiplying the whole axis. And so it's gonna be 2 pi 400 times 1/1000, and it just equals 4 pi over 5. And so you're just gonna do that for everything here, and this answers that you get after you multiply everything. And then, so that's for your discrete signal. And then, so we're going to do discrete output. And so for discrete output, it's really easy actually. So we have our filter, and we have 2 pi over 5, and yeah, so we have 2 pi over 5, and so everything else is 0 except for when it's 2 pi over 5 or negative 2 pi over 5, that equals 1. And so yeah, so we're going to multiply that by our discrete signal. And then, so I wasn't really sure, but it looked pretty linear, so I'm like, oh, that's 500. So I just had the height as 500. Hope that's right. And yeah. So everything else is 0 when it's cut off over there. And then, so this is your discrete output. And then, so we're gonna have our continuous output. So we're gonna convert it by doing literally pretty much the exact opposite that we did going from the discrete and continuous signal. And so we're going to divide by t, and then we're going to multiply the amplitude by t. So we're going to have 500 divided by 1,000 is 0.5. And then we're going to have, for the axis, it's this boy, 2 pi over 5 times t, or divided by t. And then, yeah, and then you're going to get 2 pi 200. And yeah, that's your answer. Thank you. Oh, my touch screen is broken, so it's hard to get.